All right, so this is test 4 study guide, so I'm going through the same 25 questions that's on your study guide and the same 25 that's on my test. And I will say a lot of problems on this test are just going to be stuff y'all going to punch in on that calculator when I hit them logs and stuff. Fewer trickier. So my number one wants me to graph the equation and then choose the correct graph. So y equals 1/4 to the x. Most of you are probably going to punch this on the calculator. If you do punch this on the calculator, use parentheses. Just like they got. Do your parentheses, 1 divided by 4, close them, and then hit it with that exponent, okay? I'm just going to make me a little table real quick and pick me about 3 numbers just so I can see what this graph will look like. So if I put a 0 in for x, anything to the 0 power equals 1. Put a 1 in for the x, 1/4 to the first power would be itself. It would be a 1/4. And then if I put a 2 in there for my x, when you square a fraction, square the top and the bottom. So 1 times 1 is 1, over 4 times 4 is 16. So that will give you a 1/16. So my y values are getting smaller as I go. So 0, 1 sits right here. Then I had 1 and 1/4. And then I had 2 and 1/16. So it's just going to keep trying to get closer to that x-axis, okay? So it's going to come down and just sort of try to hug the x-axis. They got 4 distinct pictures. One will look like that, one will be going uphill, and then the other ones will be on the next side or something. They're just going to keep moving it around. You put that on the calculator, Roscoe? Yeah. If you got that graph like that? All right, there you go. All right, number 2, I probably won't graph, but I'm going to tell you how you would graph an impact graph, okay? Because it's one of those where you had to move them. So the second one has f of x equals 2 to the x minus 1. So they'll have 4 choices. So you got to start with graph y equals blank to the x, and then shift it. Now they'll have 4 different shifts: shift left, shift right, shift up, shift down. Okay. The graph you're starting with, what you're going to put in the blank is the base of your graph, which is the 2. Don't put the x, because they already put the little x there for you, okay? And then that -1, anytime we attack the x as an exponent, it's going left or right. It's going left if that's positive and right if that's negative. So I got a -1 on mine, so it's going to move right. So it's going to shift right 1 unit. Now, I'm going to tell you what you would do to graph this. So to graph, click the graph, it looks like the curve. So you're going to click that curvy graph and then click it into the graph. So you highlight the curve, click the graph, and remember it puts the line on there for you. But then it opens up that box. So since I'm moving right 1 unit, I'm looking for the horizontal mover. And I'm going to shift that horizontal over there until I hit the 1, okay? That's one that had a little slide controls for y'all. But let me tell you, the important thing on this problem, down here in the little corner it'll say base.
Yeah.
By default, it has an E here. But that E is not my base. So whatever your base is to 2, you gotta come down here in that box and put that 2 in there. I've had half my students missing that because I'm not changing the base. Now the graph will look just the same, but it's gonna be off just a little bit down there. It's hard to see, you know, in small values. But if it stays at E, it's gonna make it wrong. Okay, so definitely, that's the most important thing on this is to change that base to a 2 down there, okay? When you do that, it moves the graph for you. You just hit save and be done with it, okay? Now, you can check them on your calculator though, right? To make sure it looks like the graph on there. Just go to y equals and put in 2, and then the exponent will be x minus 1. I'm gonna see yours do that. And then do the exponent, and then x minus 1. And then grab that, and I'll show you. And you'll see how it sort of pulls it to the right. Okay. And it still, it looks like a little tool you're going to grab with that little curve to it. Now, 3 is the same way. And I'll tell you what, I would click on it to do that graph. So 3 is f of x equals 2 to the x plus 3, and then it's minus 5. So it's going to do this, start with graph of y equals blank to the x. And then it has the shifting. Shift blank 3 units. Shift blank 5 units. So these are the little parts you won't fill in before you even touch the graph. So my base is again a 2, I guess. So I'll put a 2 in there. They've already got the x. So they want to know what shift I would do with the 3. Well, that 3 is up here with my exponent. And we just said if it was positive, it's going to move left. So it's going to move left 3 units. Now the end here, that's up or down. Up if it's positive and down if it's negative. So this will definitely go down 5 units. So to graph that one, you do the same thing. Click the curvy tool, then click the graph. Once I click the graph, it's going to open up the box. So you got 2 moves. You got to do the horizontal. Horizontal looks like I would move it left until I hit -3. Vertical, I would move left until I hit, what was that, -5? That's the one where you slid little controls and it moved that graph for us. But the important part, remember the important part, down here in the left corner, it says base, and you got to change that to the 2. Now, I did notice sometimes when you do the problems, if you change the base on one problem, sometimes it changes it on the next one and it keeps the 2 as the default. But if it's not doing that, it's going to keep an E there, and you got to change the E. Now, then we started getting into some of these interest rate problems. So my number 4 says, suppose $68,000. So $68,000 is invested at 6.5% interest. Compounded quarterly. So the first thing they want me to do is find a function for which the investment grows after T years. So let me give you the general formula, and then we're going to work that formula into what they want. So the formula you're going to use for this problem is A equals P times 1 plus R divided by N raised to the N times T. P is the principal, so I'll write that real quick. P is the principal, or starting amount. R is the interest rate. It needs to be in decimal form. N is the number of compounds a year. And T is the time in years. So that's what all these little symbols are meaning on this, okay? So what I got to do is write this to where it's in terms of the time. So since T is my variable, because the amount that you invested depends on how many years you had it invested, right? My principal amount is my starting amount. They gave me that, $68,000. So this is going to be 68,000 times 1 plus R. So let's see, 6.5%. 6.5% is the same as 6.5%. So to turn that percent into a decimal, you're going to take the decimal and move it left 2 units. So if we move the left 2 units, we're going to get a 0.065. Okay? So I had to add a 0 here to get my 2 moves. So R is 0.065. N, the number of compounds. So what's quarterly? 4. And then times 4, which is my N again, times T. This is the general formula they want, except you see all this stuff inside the parentheses can be worked. So to get this right in Math Lab, you gotta work what's inside them parentheses. So when I did 1 plus 0.065 divided by 4, that gave me 1.01625, all raised to the 4 times T. Now, if I know the number of years, I can find out what the amount of money is in this investment, okay? Which would be part B on this. They give me 4 years and they want me to find the amount of money in each of these years, okay? So let's see, mine gave me, so part B would be, they give me T equals 0, 4, 7, and 10 years. They want me to use these times on this formula and see what we get every time, okay? So T of 0 will be A of 0, which will equal 68,000 times 1.01625 raised to the 4 times 0. So I'll put 0 in for that T. If you work that out, well, 4 times 0 is 0 on the exponent. Anything to the 0 power equals 1. And 1 times 68,000 is 68,000. So if time is 0 means this is the first day you put that money in the bank and you put in 68,000. By God, you better have 68,000 in that bank, okay? Now, realize that each one of these years as they go up, that 68,000 better go up, okay? So what was next? A of 4. So I'll do my 68,000 times 1.01625, And then my exponent will be 4 times t, which is 4. So y'all pushing that in the calculator, working it, you should get $88,007. Which means after 4 years, that's pretty much what, $20,000 they made, okay? But you know why? Because that's pretty high interest rate at that 6.5, okay? All right, what's next? A07. Real world, they're probably not that generous with them interest rates, are they? So the only thing I'm going to do is change my years to a 7, so that'll be 68,000 times 1.01625, and the exponent will be 4 times 7. Putting that in on my calculator, I ended up with 106,789. Now, some of these might have decimals. They're wanting me to round all these to the nearest dollar. So y'all, when y'all put these answers, make sure you look down there and see that they want these in the nearest dollars. Some of these want them in the nearest cents, okay? All right, last one, A10. But I'm happy I'm seeing my mouse going up each time. So A10, change the 7 to a 10. So after 10 years, I came up with $129,000, 578. So if you started with 68,000, 10 years, you doubled your money pretty much. Okay. So that's just what they wanted y'all to see was that formula and stuff where you got these exponential type numbers on. Okay. All right, let's see. 5 is the same type of problem. But 5 is the one where they gave you the little girl with her birthday. So on Melissa's 6th birthday, she got a $3,000 CD that earns 4% interest, compounded semi-annually. If it matures on her 12th birthday, how much money is available? So once again, we're going to use this formula, the A equals P, put in everything we got, and we'll find out what that amount is, okay? So here we go. We got A equals P. P is the $3,000 we started with, times 1 plus R. Well, R, let's see, is 4%. Turn that 4% into a decimal. So you would move it left twice. So that would give you a 0.04. So what would y'all put for semi-annually for my compounds? 2. There you go. And then that'd be times 2 times T. So T, we got to figure out because we know she got it on her 12th or 6th birthday, and it matured on her 12th birthday. So that would be 6 years. So just figure out her years from the maturity till when she got it, which was 6. All right, let me see what they want me to round this one to. Round to the nearest cents. So 2 decimal places. So I came up with on that one $3,804.73. So hers didn't grow as much as this, but she invested a lot less money at a lower percentage rate, okay? So in 6 years, the little girl made $800 though, right? So now you know how they all get cards when they're 16, right? All right, y'all. Then you break out the calculators. Because a lot of these are finding logs, and we find logs on a calculator, right? So I'm just going to write find the logarithms for these next few problems. So I was on number 6. So I'll do this one. Log base 10 of 0.001. Now, since that is a base 10 log, you can use the log on the very front of that calculator. Any other base, you got to hit the math button and go and find the log base in there, okay? So just push in log 0.001 and that'll spit out. Hopefully y'all are getting 23. Let's see, this one has log base 6 of 6 squared. So on this one, I would go to math, down to my log base, hit enter. Your base is the 6. And then punch in 6 squared for that result there. Hopefully you're getting that. Oh, okay. So let's get you on that. Do that again. But you see how I got it up there? Put your 6 here, and then put your 6 and square. So because the exponent's got to be in with it. Because when you punch that, you should get a 2. And y'all, anytime this base matches this result, the answer will always be the exponent. Now yours might not have log base. If you got the old one. So what you would do in that case, if you don't have a log base, is you would do log, what was on top, 6 squared. So do the 6 squared in parentheses, and then divide by the log of the bottom number, which was the 6. So it's the result always divided by the base, okay? And when you get in it, you're going to get a 2. So like on this one, you would do log 3 divided by log 27. Log 1 divided by log 34. Okay? All right, let's see. 8, y'all, is log base 27 over 3. But push that one in, let's see what you get. And I sort of always remembered it because this number was up higher. So I always knew this number was on top and then divide it by this one. But close in parentheses before you get to the divide bar, okay? So you'll do log of 3, close parentheses, divided by log of 27. If you get a decimal, turn it into a fraction. And hopefully y'all are getting
Do you mind going over or writing?
All right, what's writing online?
Oh, yes. So I have an older calculator too. And I know that you're, because like I didn't see log base on mine either. So what are we typing in? I know we're supposed to put it in parentheses, but.
So if you do not have the newer calculators with the log base, to get your answers, you're going to take the log of the result, which is the higher number in the problem, and divide by the log of the base.
Okay.
And on every one of these, you just take the log of that result, divide by the log of that base, and you're going to get the same answers.
Okay, thank you. I just wanted to make sure I understood what I was putting in there.
Mm-hmm. Yeah, it does
Appreciate
the same thing. You just got to do the old method instead of these new methods they got.
Gotcha. Thank you.
Now, Roscoe, yours got this, so you spit them in, and it's going to give you 0.333, hit math, and turn them back into fractions.
Yes, right.
Log base 34 over 1. So, Brenda, Janelle, y'all are going to be having log of 1 divided by log of 34. This one has a unique answer. Hopefully y'all getting a big old 0. And I'll tell you what, anytime that thing is a 1 right there, anytime it's a 1 there, it's going to equal 0 for that exponent, okay? All right, next we start converting to logarithmic equations. So this will be 10. So we got 2 converting to logarithmic, and then I think I got 2 converting them to exponential. So 10 to the 6 equals 1 million. So they want me to rewrite this using a log. So there's my log. My base of my log is the 10. It's the same thing as the base of the exponent. The result is the 1 million. That's going to equal the exponent, which is the 6. So you got to get used to this whole logarithm expression on the left side. All it equals is that exponent of the 6, okay? So 2 of these. So my second one, oh, you know, they like to use these letters. So e to the -5 equals m. So they want me to write this with a log. So let me write log. My base is the e, right? Base e. My result is the m, and that's going to equal the exponent of a -5. Now, although that's a right answer, that's not what they would consider the most simplified form of that answer. Because there's something I can use instead of log base e here. How about a ln? Remember, ln is a natural log, and it's the log base e, okay? So if you end up with a log base e, you gotta change it to the ln of m equals -5, okay? So that's one of the things you gotta watch for on this test. And this is the only problem where you'll get that. But just remember on number 11, when they use the e, we gotta end up in the natural log, okay? Well, it's warm in here. Is it nice getting me hot? And I'm like, getting hot. Is it warm in here still? Okay, this might, I'm going a lot hot air. All right, now going the other way, we're going to convert to exponential. So 12, they're giving me log base 2 of 16 equals the exponent of 4. So, go reverse, right? The base is the 2. So bring down the 2. The exponent is the 4. And 2 to the 4 has to equal 16. That's a true statement, right? 2 times 2 times 2 times 2 is 16, so we know we're good. Now 13, they're gonna make a little different because they're using letters. So log base n of t equals negative x. So y'all on this one, it's really, really picky. If they use capital letters, you gotta use capital letters. And if they use, what do you call it, lowercase or something like that, then you gotta use those too, okay? So the base is the n. The exponent is the negative x, and that's going to equal that dt. There you go. All right, let's see. 14 actually tells you to use a calculator. Anytime you're using calculators, you're going to round these 4 decimal places. Actually, I think every one of them where you had to round them was going to 4 decimal places, okay? So they want us to find the LN of 880.1. You know, the LN, you can use the one right on the front of your calculator. So let's see, I'll punch in LN 880.1, enter. So 4 decimals after, so I get 6.78. And then I got 003, so that's just going to say what is 00. And you're done. Okay. Well, let me get it running real quick. Getting hot and dry. So really, for Janelle and Brenda, there's only probably 2 or 3 at the most where you had to do that. The rest of these should be like punched right on the calculator.
Okay.
All right, so what's that? 15. So 15 actually says find logs using the change of base. That's what I showed y'all. Change of base is what that's called. But for everybody else, I'll use the log base, okay? So one way or another, find this log. Log base 3 to 14. So once yours in, I'm gonna see what y'all get, Brenda and Janelle. Now you're gonna go to log base on yours. There you go. So I would predict something between 2 and 3. What am I doing? 15. So what do you get? 4022?
4, yeah, 2.
4022. Do you get that? Okay. All right, 16 expressed as a sum of logs. They're giving me log base 18 of 18 times 324. So y'all think about this. They're saying, right, this has a sum of logs. Well, when we're done, something's going to be added on this, okay? So basically, if they're multiplied, you write them as a sum. If they're divided, you write them as a difference. Distribute this log 18 to both of these. So you're going to get a log base 18 of 18 plus the log base 18 of 324. All right, ooh, I did, I'm gonna have 16, y'all. This will be 17. Right as product. Anytime you see right as product, all that means to me, when I see that, move the exponent to the front. You remember? So move the exponent to the front. That's all this means. So let me see what they actually gave me. So 17, they gave me log base P of x to the 16th. Well, hell, take the 16 and move it to the front. So now you have a product of 16 times log base P of the x. Okay. A lot of these ain't bad if y'all play with them. I ain't gonna lie, I got a few in here that's sort of tricky. 18, write its sums or differences. Also, you're going to write it as sums or differences, and when you're done, you better move those exponents to the front. Okay? So they're giving me a log base C of x to the third, y to the eighth, and a z. So we won't have no differences on this because we don't have any division. So since they're all multiplied, I'm going to write it as a sum of logs like I did on this problem 16. There's three factors, so you're going to have three factors when you're done. Log base C of x to the third plus the log base C of y to the eighth plus log base C of z. So it's rewritten as the sums or differences. And now, two of these have exponents, and I'm going to move these exponents to the front. So I get 3 log base C of x plus 8 log base C of y. And then the last one didn't have an exponent, so I'll just bring it down as a log C of z. I'm going to let y'all catch up on that because the next one's got the division and it's a little hairier. Excuse me a break, please. Shut my mouth a little bit, cool it down. Hopefully in the fall we don't have to wear masks up in here.
Oh, I hope not.
Hey, I said, what's that, 19 coming up? Rewrite its sums and differences. Or both. Well, this one actually had an and in there instead of or, so you want to do both, okay? All righty. Log base B of P to the third, Q to the sixth, all over, M to the fourth, B to the ninth. Remember this, if they're on top, when you rewrite them, they're going to be added. If they're on bottom, when I rewrite this, they're going to be subtracted, okay? I will distribute the log base B to all four factors. All right, y'all, so here we go. We're going to have a log base B of P to the third because it's on top, minus a log base b of m to the 4th, minus a log base b of b to the 9th. So 3 of them I'm going to move exponents to the front, and 1 of them I'm not. You'll see this log base b of b to the 9th at the end. This whole term right here equals 9. If any time the base matches the result to an exponent, the answer is going to be the exponent. These other 3, I'm going to move my logs, my exponents to the front. Okay. So had that been minus log b of b to the 10th, then that would equal to 10, and so on, okay? All right, so let's bring the 3 down. We get 3 log base b of p. Bring the 6 down, so that's plus 6 log b of q. Minus, bring the 4 down, 4 log b of m. Minus, y'all, that log b, b to the 9th equals 9. Okay. That one, if you'd have done it on homework, you need to put minus 9 log b of b. The log b of b is 1, so it would have probably said, although you're correct, you're not in the right form. Oh, y'all good on that? So it's just a matter of positive stays, top is positive, bottoms make them negative, okay? All right, we're good. So I got 30 minutes. All right, simplify. So these ones will be simplified. And I think I got 2 doing that, okay? ln of x squared plus 5x plus 6 minus the ln x plus 3. They're being subtracted, so we're going to rewrite it as division. Pull out that ln. This part's positive, so it's going to the top. This part's being subtracted, so that factor is going to the bottom. Oh, so we got the answer, but it's not simplified yet. To simplify this, anytime you got trinomials, you want to factor them. Now, the bottom I can't factor because that's just the x plus 3. But I do got to factor the top. So, x and the x, because of that x squared. That 6 is positive, so both of these will be positive like that, 5 in the middle. And y'all guess what? I know what one of these factors has to be. If I'm going to simplify this, one of these better be an x plus 3 up here, okay? So factors of 6 that equal 5 are 2 and 3. So you put in your 2 and your 3. But I need to give y'all a factor program on that calculator too. Just punch into 1, 5, 6 and it'll spit it out too. Make sure I gave you, I think I gave you that too. So factor program will be in the program button and number 7. And then hit enter. And then do the numbers like you did quad. So I would have did the 1 enter, 5 enter, and then 6 enter, and it would spit out your answers. Did I give you a quad? Okay, you got it. Because the reason I did that, because this simplifies, because those x plus 3s will cancel, and we end up with an ln of x plus 2. Now, where I get a few people is they don't keep it in parentheses, but that since since every other factor went away, you got to keep it in parentheses, or it'll be thinking it's like the ln of x plus a 2. It won't do the ln of the whole thing. Okay. All right, 21 is the same thing, so you got to factor on these couple problems for sure. So I'm still simplifying. This time it's a log. Log x squared minus 5x minus 6 minus log x squared minus 1. So they're being subtracted, so it's going to look like a fraction again. Log x squared minus 5x minus 6 over x squared minus 1. Both of those will factor. Now, y'all listen here. On that bottom one, when you factor it, the b is 0 on the bottom one because there's not an x here, okay? So what you get on that column?
X plus 1, x minus 6. That's what I'm saying.
You get a 1 and a 6. You did like that?
Yeah.
That's perfect. Now do the bottom. Do a 1, 0, and do 1 for me. And by God, it better be one of these two factors in that number, or I ain't simplifying nothing, okay?
One, 0.
And a -1 at the end.
Plus x plus 1 and the x minus 1.
Perfect. Guess what? I'm gonna cancel out the x plus 1s on this one, y'all. So those cancel, and I end up with a log of x minus 6 over x minus 1. Now let me show you. I don't have to put this one in parentheses because it's a fraction, and the top of a fraction and the bottom of a fraction are automatically treated like they're in parentheses. But had this not been a fraction, I would have kept them in parentheses, okay? All right, so those two you definitely had to factor. Then I think you got one more or two more that you got to do a little factor on. All right, 22. Okay, the rest of these are just going to solve for x. So I got 4 more equations. So the first one, I got 2 to the 5x equals 4. So you're going to have 2 of these exponential equations. One you're going to be able to rewrite, the other one you're not. I can rewrite this one. So I'm going to rewrite 4 as 2 squared. Since I got a base of 2 here, I wanted that side to have a base of 2 also, okay? Because now I'll have 2 to the 5x equals 2 squared, which means my bases match. So these bases match. Any kind of bases match, that means the exponents are equal. So 5x has to equal 2. And I got one more move. I'm going to divide both sides by 5. So that x is 2 divided by 5. Okay? So the first exponential, rewrite that base. If they give you a base 3 and other numbers are 9, rewrite 9 using the 3 as an exponent, or 27 would be 3 to an exponent or something like that, okay? Now, the second one that you got this exponential, number 23, you're not going to be able to rewrite. So let me see, 23, I actually had 2 to the x equals 9. So you can't multiply 2 to get a 9. 2, 4, what's that, 8, 16? No way to do that. So since you cannot rewrite, when you cannot rewrite it, you gotta take logs of both sides. Because by taking logs is the only way I can get them exponents and bring them down, okay? So I got the log of 2 to the x is going to equal log of 9. So just curious, what is the next move?
Do we subtract?
Well, hang on to that just a second.
Okay.
9.
Divide?
Oh, I'm going to get all y'all. Okay. Bring the exponent down.
Oh.
That's the whole reason we do the log is so we can bring this exponent down to the front. So I get an x times log of 2 equals a log of 9. And see, that's the only way I can get that exponent brought down is by doing them logs to it. But now that it's brought down, I'm going to divide both sides by log 2. Right? If x is being multiplied by log 2, we're going to divide by log 2.
Gotcha.
Because log 2 is really a number. We don't know that number, but it's probably a long decimal type number, okay? So, because those will cancel on this side. And then I have log 9 over log 2. So that x equals. Now, when you punch this in that calculator, you're going to punch log. It's going to give you a parenthesis. Close that parenthesis on that 9 before you hit that division. And then put the log. It'll give you the first parenthesis. Put your 2 and then close it. You got to close the parenthesis on the 9 or you will miss this, okay?
Okay.
So what is the log of 9? So let's see if y'all do that right. Log of 9, close parenthesis, divided by log of 2, close parentheses. So if y'all did that right, y'all should get a 3.169, and then it's going to stay at 9 because I got a 2 after that. Is that what yours says? Yeah. So the main trick on that is when people do this, a lot of times they'll forget to close this. And if you don't close this period, this thing, you're actually finding the log of 9 divided by log of 2. It's like a fraction instead of like we need to time. All right, good one to go. So we're doing good on time. So then we ended up with 2 logarithmic equations. Those 2 equations I just did were exponential. These are going to be logarithmic. So these will say solve for x still. Which one? 24. I got log base 5 of t plus 21 minus log base 5 of t plus 5 is going to equal the other side, which is log base 5 of t. Now, remember, this is a logarithmic equation. When you're doing logarithmic equations, you cannot keep negative answers. Negative answers are, when you try to take a log of a negative number, you get an error message because they're imaginary. So throw the negative answers away and only keep the positive ones, okay? Because MATLAB will mark you wrong if you put the negative answer. So the first thing we have to do to logs is combine logs when we got more than one log on each side. So since they're being subtracted, it's going to look like a fraction. So bring out that log 5. T plus 21 is positive, so it goes to the top. T plus 5 is being subtracted, it goes to the bottom. And all that's going to equal the log 5 of T. Now this looks crazy, but we're about to make this look a lot nicer because both sides have a log 5, right? So this is sort of going to be like this property. These log bases match. Since my log bases match, I know this result equals this result. So T plus 21 over T plus 5 is going to equal T. Okay, so log bases match, it's just those results that them equal to each other. I'm going to cross multiply this by putting a 1 under there and multiplying this top times that bottom, this bottom times that top. So T plus 21 times 1 is going to give you T plus 21 equal to the other side. T times T is T squared plus 5 times T is 5T. So the easiest way to do fractions to me is just cross multiply these things. Now, you got a T squared, so this side needs to be a 0. So I'm going to subtract a T and a 21 from both sides and see what that gives me. So let's see, this side's going to be 0. That's going to equal T squared. 5 minus 1T gives me 4T, and then minus my 21, okay? And y'all remember, anytime you have these T squareds in there, you got to get it on one side equal to 0, and then you're going to factor it. So let's see if y'all can factor now. Y'all got my factor program, let's see what y'all get. And remember, instead of X's, there's actually T's on this one, but y'all can't punch T's on that. It's going to give you X's. Just remember it's T's in the math lab, okay? Who's getting? Oh, he's going to make it. And then negative 21.
7 and 3.
And the 7 is positive.
Yeah, the 7.
And what's the 3?
7 and 8 minus 3.
And then there you go. So just remember, when y'all put them in math lab, if you use that program, those X's are really T's in math lab, okay? All right, then set both these equal to 0. So I'm going to subtract 7. I get T is negative 7. Add 3. And T equals a positive 3.
But we can't have negative, so T
Oh,
equals.
you know what? You did good. I was just want to keep on going and see what y'all said. And then before I wrote my 25, I was going to say, can we take those answers? No, we cannot take this negative answer, and the only answer is
Positive.
so y'all got saved by the online today. Good job. Y'all, then there was one. So let's knock out the last one. And y'all's problems are going to be pretty much exactly like mine. Just work them like we did here and just change those numbers up if you got to, okay? Get used to it. Do that study guide as many times as you want. At least you get 70 if you want the bonus, okay? Woo, okay, y'all, last one. So log base 6 of x plus 8 plus log base 6 of x minus 8 equals 2. logs on the left side, we gotta combine those. So it's gonna be a log base 6. These are being added, so we write this as a product. X plus 8 times x minus 8, all this is still equal to a 2. And now I'm going to do one more step. Before I actually rewrite this, I'm going to work that. I'm going to FOIL that out and see what I get. If you FOIL that out, you would end up with an x squared minus 64. Because what will happen is the 8x and the negative 8x will cancel out and make a 0 in the middle. All this is still equal to a 2. Now, y'all, real quick, I'm going to show you how that works on the x plus 8, x minus 8. So I'm going to show you how I got that x squared minus 64. So I did x times x was x squared. X times negative 8 is a negative 8x. 8 times x is a positive 8x. And then the 8 times negative 8 is negative 64. But you see these in the middle? They got it. So those canceled. So I ended up with my x squared minus 64, okay? All right, can I do nothing else to this? So now I'm going to rewrite as exponential. So you'll see what we did. I gave you one exponential where you could rewrite it with the same base. I gave you one exponential where you had to rewrite it as logarithmic to solve. I gave you one log that had the same bases on each side. And then I gave you one log that didn't have the same bases on each side. So if they got the same bases, you set the results equal. If they don't, you got to rewrite this as exponential. So the basis is 6. So what's the exponent of that 6 going to be? So I'm rewriting this as exponential. Where's my exponent going to be right here? Damn, saved by Roscoe today. Remember, 2 is the exponent. Remember, that's what a log is a exponent, okay? So 6 squared is going to equal that result, which was the x squared minus 64. Okay? Well, I'm liking this. I had a quiet young man over here at the beginning of the year. He was trying to math, been out of it for about 10, 11 years. Now he's talking of an answer. That's what I like. See? You talk to the bit. Everybody online pretty much talks you now. And then we got half the time we don't even know who they are. Never seen them in my life. All right, y'all, here's what we're going to do. 6 squared is what, 36? So 36 equals x squared minus 64. Since we got this x squared, I'm just going to bring everything on one side by subtracting the 36. So now I got 0 equals x squared minus 100. So we need to factor the x squared minus 100. Remember, 1, 0, negative 100 to factor that. So what number y'all get on that? 10, okay? This would be what, x plus 10 is minus 10? Which means I'm going to get 2 of the same answers, but just have opposite signs, it looks like. All right, y'all, so the first one, I'm going to subtract that 10. I'm going to get my x equals negative 10. Second one, I'm going to add 10. And get x is a positive 10.
So the answer is x equal positive 10.
Y'all hear that? I got another negative answer. We're gonna kick it off. Good job. So the only answer is X is a positive 10. Y'all, your 25 questions is gonna be the same order as mine on that study guide. But now you should be almost able to get a 70% just doing the calculator part of it already. You know what I mean? It's punching in logs and getting them answers out of that. Y'all, you're done with me for the year. Other than Monday, if you want to come and have a study guide for the final with me, I'll be here Monday for y'all.
Okay.
Going over that study guide, okay?
All right. Thank
We'll
you.
be on
Now-
Zoom Monday.
Y'all, if you haven't registered for y'all's classes yet, get on there and get them, because I was registering the student the other day and them classes are going fast.
Oh, all right.
So if you
Are
want
you
to make a good schedule, get on there and get them picked, okay?
Thank you.
Are you doing Zoom Monday for the final study guide?
Say again?
Are you doing Zoom Monday for the final study guide?
Yeah, I'm gonna do in class and Zoom like we did today.
Okay,
All right, I'll see y'all Monday.
okay.
Bye.